you've got this what's called an antiderivative, 3 over x squared plus x minus 2. I'm going to introduce a technique called partial fractions. And what that is that's rewriting this, all right? This is a tool that you're going to use in calculus. We learn a variety of different techniques, power rule, use substitution, long division, and a lot of different techniques that we learn. This is a Calc 2 subject that we're covering now, so what I'd like you to do is consider this technique called partial fractions after all of these have been exhausted. In other words, if you attempt to use all of these techniques and nothing seems to work, you would then try to use this technique I'm going to talk to you about now. It's called partial fractions. Partial fractions. All right, so let's begin. All right, so what you're going to do, first step is you're going to factor this. 3 over x times x plus 2 times x minus 1. All right, so this is the same thing as this. Excuse me. So this is the same problem. And what you're going to do is you're going to attempt to rewrite this. So let's rewrite this as some variable over x plus 2 plus some other variable over x minus 1. So you're going to this is something where none of these techniques worked. So we're going to use something called partial fractions. We're going to turn this in, we're going to use partial fractions to evaluate this antiderivative. All right. So now what you have is let's take this equation, let's multiply it by the least common denominator, which is x plus 2 times x minus 1. We multiply this times x plus 2, x minus 1, we get 3. We multiply this by x plus 2, x minus 1, we get a times x minus 1. And then we multiply this times x plus 2, x minus 1, we get b times x plus 2. All right. So now what we have is we just have some equation, some very, very general equation that you can always just substitute into. And what we're going to do is we're going to substitute in, strategically, 1. You'll see why we're substituting in 1 into this in a minute. But let's just substitute in 1. If we substitute in 1, we get 3 is equal to, if you substitute in 1 here, this goes away. That's why we substituted in 1. Is equal to b times 1 plus 2. So you end up with 3 is equal to 3b, and b ends up being 1. All right, b ends up being 1. So now what we're going to do is we're going to do the same thing, but let's substitute in something different. Let's substitute in x is equal to negative 2. Hopefully you see why I substitute in negative 2, because that will get rid of that b. All right, so now we have 3 is equal to a times negative 2 minus 1. And then if you substitute in negative 2 here, the b goes away, and you get 3 is equal to negative 3a. You divide by negative 3, and you get a is negative 1. So now what you have is you have a situation where you are trying to rewrite this problem. So instead of 3 over x plus 2 times x minus 1, you have now an antiderivative of a over x plus 2, which is negative 1 over x plus 2, plus b, and b is 1 over x minus 1. So this is now a technique where you have just rewritten the problem. This was the original problem, but this is the same thing as the original problem. But it turns out this is much easier to take the antiderivative of. Much easier to take the antiderivative of. All right, so now what you're going to do is you can pull out that negative, you can pull out this negative, and you end up with the antiderivative of 1 over x plus 2 plus the antiderivative of 1 over x minus 1. All right, So this ends up being negative. The antiderivative of 1 over x plus 2, you could show a little work, but you're going to end up with the natural log of x plus 2. And then you could show a little work here. You could substitute u to be that, u to be x minus 1, but you're going to end up with natural log of x minus 1. Okay, x minus 1. And then you're basically done. What's going to end up happening is you're going to end up being able to condense these two natural logs. You'd end up with the natural log of x minus 1, x minus 1 over x plus 2. And that's going to be your final answer. You can condense two logs to be 1. All right. So that's your final answer. Okay, that's your final answer. The book might have one big absolute value, but it's the same thing.